Today's lesson is on modeling with linear and nonlinear regressions. So it's all going to be taking a table of values and then coming up with an equation to model those values. This is going to be very, very calculator heavy. So you're going to want your calculator, and I'm going to go through all the steps. Okay, so our first question, whether you are climbing a mountain or flying in an airplane, the higher you go, the colder the air gets. The table shows the temperature in the atmosphere at various altitudes. So first we're going to make a scatter plot. So in the calculator, we need to enter this data in. So you're going to use this stat button. So we do stat, edit. If you have anything already in your list, you're going to want to go up to your list and hit clear, then enter. So in my list 1, I'm going to do 0, 1,000, 2,000, and then my corresponding values, 15, 13, 11, 9.1, 7.1. All right. Now what we're going to do is you're going to go to y equals. If you have anything in your y equals, either delete them or unselect them. Then we're going to go up to second stat plot. Okay, we want our plot to be on. We want our type to be a scatter plot, and we want our list 1 and list 2. If those are not there, if it's something different, above the 1 and 2 button is list 1 and list 2. So you would just do second and that. Okay, now to do the scatter plot, we could certainly fit the window because we know the values, but a quick way to do it is to do zoom, and then option number 9 is zoom step. And there's our scatter plot. Okay, so the question on our notes says, what type of function do you think would model that? Well, that's looking pretty darn linear. So I think a line would be a good type of equation. So what we're going to do is use the calculator to find that. All right, so we're going to get out of here. You're going to go again to that stat menu. Now we're going to go to calc, and there's lots of options here. The one we want is number 4. The linear regression, and we can tell it's a linear because it even gives us the equation of the line. Okay, so we want list 1, list 2, and we're going to store it in y1. Okay, so if you do alpha F4, that gives us the shortcut menu for y1. Then we're going to calculate. So it gives us this as our regression equation. Okay, so we're going to plug those values in for A and for B. Negative 0.0197x plus 14.98. Okay, if we go to our graph, because I stored it in y1, okay, that equation seems like a pretty good fit for those points. Okay, then I can predict at 5,000. Okay, I have in y1 is that linear equation. It's stored it in there automatically. So I can just do y1 evaluated at 5,000. That would be degrees Celsius. All right, so another set of data. So in our calculator, we're again going to go to stat. We press our stat button. Edit. Okay, now I want to get rid of the stuff that's in there. So you highlight the list and do clear, enter. Clear, enter. Do not hit delete. Okay, so we're going to have 0, 1, 2, 3, 4, 5, 6. So this is growth of bacteria. And then in our Y2, or list 2, All right. So now we're going to go to y equals, get rid of that regression equation. I still have my plot set up, so we don't have to redo that, but we do need to redo our window. So zoom stat gives us this. Now this one, instead of being a straight line, is kind of curving up. So we've been dealing with exponential functions, so that looks pretty exponential to me. Okay, so we're going to do the regression equation, this time exponential. So stat, calculate. The exponential regression is down here. List 1, list 2, and we want to store it in y1. Okay, so there is our exponential equation. Okay, so we plug in the two values they gave us. It was a times b to the x, my a being the 399, my b being the 1.189, gives us this. Okay, I stored it in y1, so if I just hit graph, it's going to graph our exponential regression. Looks like a pretty good fit. Okay, last we want to predict after 24 hours. So we'll do y1 evaluated at 24. And we can round to the nearest whole number here, makes sense. Okay, our next set of data are life expectancies according to birth year. So I'm going to type these into the calculator like I have been doing. But instead of 1910, I'm going to do 10, 20, 30, and so on. Okay, so I've gone ahead and put this into my calculator. Again, shortening the dates. Here's our life expectancies. So go to y equals, get rid of that equation. Our stat plot's already set up from before. So if I just do a zoom stat, we get this. So this one, rather than going up like the exponential or going through a line, it's increasing, but it's kind of increasing at a slowly gradual rate. So this is going to be logarithmic. Okay, so we're going to do a logarithmic regression. So we'll go to stat, calc, the natural log regression, stored in our y1. Okay, so the general formula here is a plus b natural log x. So we'll fill this in for the a and this in for the b. So there's our equation. Let's go ahead and check out the graph. Okay, and again, looks pretty good. And then we can predict for 2030. So that's going to be y1 evaluated at 130, which will be 79.5. For our next set of data, if you're in class, we'll do a simulation here. But you have one person who knows a rumor, and they tell one person. The next day, that means two people know the rumor, so those two people tell two people. So then you get 4 people know it. Those 4 people tell 4 people, so then 8 people know it. Now, at some point, this is in a limited population of 25 people, the people telling might be also telling people who already know the rumor. So I ran this as a random simulation, and it took 8 days for all 25 people to know the rumor. Okay. So in the calculator, I'm going to just do a stat plot for the first 4. Okay, so in my scatter plot, stat, edit, we're going to clear, so this is 1, 2, 3, 4. In my L2 is 1, 2, 4, 8. Get rid of anything that's in your y equals. And then we're going to do a zoom stat. Okay, so that looks pretty darn exponential. Okay, so let's add on the rest. So we're going to have 5, 6, 7, 8. Then we have 14, 19, 22, 25. Now if I do a zoom stat, okay, it starts off exponential, but then it starts to level off, which should make sense because if there's only 25 people, it's going to have a limit there. Okay, so this is called, oh, well, this says, is this the type of function, does exponential seem to carry over? Nope. So a graph that starts off exponential but then levels off is called a logistic function. Okay, so logistic is one of the regressions that we can run. So we'll do stat calc, and it is simply just called logistic. We want to store it again in our y1. Okay, so this one is c over 1 plus a e to the negative bx. So a, b, and c. So this is y equals, you have your calculator in front of you. The c value goes on top, 26.33. Okay, on the bottom is 1 plus a, in this case was 71.01, e to the negative 0.867x. Okay, kind of a funny looking curve. But if we go to our graph, remember we stored it in y1. Okay, that looks like a good fit. In our final example, we're going to try to figure out what equation to use. So this is the distance a seismic wave can travel from the earthquake's epicenter to the time since the earthquake. So this is the time, and this is how far it has traveled. So there's all these different types of regressions. So I'm going to fill in some of this information. The calculator abbreviation for a linear regression is linreg. The general equation is y equals ax plus b, and a graph is just, a straight line. Quadratic regression is a quadreg. The general equation is y equals ax squared plus bx plus c, and a quadratic regression would look like this. Now, it doesn't necessarily mean it decreases and increases. If you can have a quadratic regression that kind of looks almost exponential. A power regression is PWR reg. General equation is y equals ax to the b. Okay, and that's similar to exponential or even the quadratic exponential regression. AB to the x. Okay, we know what exponential growth looks like. Logarithmic is ln reg. Y equals a plus b ln x. And that's something if it grows, but it starts growing slower as time goes on. And then logistic is logistic. Okay, and that's one where it starts off exponential but then levels off. Okay, on the calculator, there's a tool that can help us with figuring out whether these are good regressions or not. Okay, so what we're going to do is you're going to go to your catalog. So second 0 catalog. Type in the letter D. Okay, and we're going down, 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 down. And there's diagnostic off and diagnostic on. We want diagnostic on, so hit enter enter. Okay, now we're going to do these different regressions. So we're going to go to Stat, Edit, and enter in our new data. Okay, so we've entered in our data, and we're going to do each of these regressions, starting with a natural log regression. Sorry, a linear regression. So second, calc, we want to do a linear regression. We'll go ahead and store it in Y1. Okay, and calculate. Now that we have the diagnostics on, we have down here what's called a correlation coefficient, and then that value squared. So R squared. R squared is used in certain statistical calculations. The closer this number is to 1, the better this is. So if we go to the graph, sorry, we need to do a zoom stat. Okay, it's not bad. It's an okay fit. The regression equation, 776.6x minus 940.7. And I'd say it's an okay fit. The R is 0.98 or so. Okay, and we're going to repeat this for different regressions. So next we're going to do a quadratic regression. So stat, calculate, quadratic regression. Stored in Y1. So we get Y equals 36.6x squared plus 264x plus 147, if we round there. Let's go ahead and take the R here, R squared in this case, is 0.99, so that seems pretty good. If we go to our graph, since we stored it in Y1, it'll graph our quadratic. That seems like a pretty good fit. Next is a power regression, so stat, calc, power. We're going to store it in Y1. Times x to the b, which is 1.25. Okay, so let's see. So R squared is 0.99 again. So we're expecting a pretty good fit. And that seems pretty good too, but not quite as good as the last one because the last one included this point. So I'd still say that one's a little bit better. Let's do an exponential regression. Okay, it's got a R of 0.96, so not quite as high. Okay, and that one's just not as good. So I'm just going to say it's okay, but not great. Stat, calculate, let's do a log regression. LNX. Okay. So the correlation's 0.90, which isn't as good. If we go to graph, yeah, not good. Okay, the last one is logistic, so we'll run one more regression and pick our winner. So we have 1,584.1.5 over 1 plus 25.1 e to the negative 0.284x. we go to our graph, it's okay, but we know Logistic is going to start leveling off, and it doesn't really look like this data is doing that. Okay, so which one? And you could argue for several of these. Both of these seemed pretty good. Even the line seemed okay. So I would probably pick the quadratic. Okay, quadric. Okay, quadratic's probably our best fit, but there could be an argument for the power equation. So that is how we do various different types of regressions based on different data types.